Hello, ladies and gentlemen. So we are going to continue our learning about how to represent and solve addition and subtraction of fractions. So we are continuing to be able to use pictures and objects to represent the sum of two fractions, using picture and objects to represent the difference of two fractions, and then being able to solve addition and subtraction with those pictures. Now, yesterday we did practice this in our mini lesson with fractions less than a whole. So today we're going to move on to fractions greater than a whole. I know that a lot of us had some difficulty with our mixed numbers and fractions greater than a whole, so we're excited to continue with this. So first off, let's talk about fractions greater than a whole and mixed numbers. So, if we look here, right, we have 1, 2, 3, 4, 5, 6, 7 pieces. And so if we look at just how we would write this as a fraction, well, my pieces are fourths, right? That means 4 of them make a whole. And I can even look at that by comparing it with a whole number over here. Yep, 4 pieces does make a whole. 1, 2, 3, 4. And if I were to count this up, how many did I have? Let me count the unit sums. 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 fourths, right? Now the mixed number is called a mixed number because it is a mix of two types of things. It's a mix of whole numbers and fractions. So, we will always have the whole number here. Oh, I should have typed this, but that's okay. We live and we learn. Whole number here, fraction here. So, as I'm looking at this, how many wholes do I have? So how many fourths can I put into a group of 4 and make a whole? Well, I have 1 here, and I don't have enough to make another. So I have 1 whole, and then I have 1, 2, 3 fourths left over. So my next mixed number is 1 and 3 fourths. And these two are equivalent. They're equal to each other. 7 fourths and 1 whole and 3 fourths are the same. Now, Mr. Connor, this sounds a lot like a decimal, this mixed number, because I have my whole numbers here, and then my pieces less than a whole over here, and you're absolutely right. Now, if I were to try to write this as decimal, I would put my decimal number right there, but we don't with mixed numbers. Just having the whole number here and the fraction here lets us know this is a separation of whole numbers and fractions. Okay, so let me change things up a little bit. Let me just do that. So, if I were to change this up just a little bit, how would I write, there we go. How would I write this number as a fraction? So let's see. I still have pieces that are fourths, right? Still have fourths. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 fourths. And how would I write this as a mixed number? Well, let's see. I have 1 whole, right? I have 4 here, so that's 1. I have 4 here, so that's another 1. And I don't have enough here. So I was able to make 2 wholes, and I still have 3 fourths left over. Excellent. Okay. So let's think about how we can add these together. So Ryan worked 1 3/4 hours one day, and 2 3/4 hours another day. How many hours did he work altogether? Now we can write this just like we did before as either a fraction or a mixed number. So let's see. If I count them all up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 unit fractions, which means my answer will be 18 fourths. But you know what? That's kind of hard to work with when I have a numerator so big. So let's see if we can make this a mixed number. I'll have 1, 2, 3 whole numbers, and then I have 1, 2, 3, 4, 5, 6 fractions. So I have 3 whole numbers, and I have 6 fourths. But you know what? I have a number larger than my denominator. So this is a warning sign telling me, hey, I can make another whole number here. So let's check. Okay. So I'm moving one of these fractions over here, and I am able to make a whole number. Let's see, I have 1, 2. That's not enough to make another whole number. So my whole number has changed. I can make 4 wholes, and I'm left over with 2 unit fractions. So 18 fourths is the same thing. It's equivalent to 4 2 fourths. So Fernando has been playing piano for 2 5/8 years, and Lana has been playing for 3 7/8 years. How long have they both played in total? Okay, this is going to be large. So let's see, we need to work with eighths. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to compare it quick. So let's see, Fernando. One moment. Okay, we fixed it. So I have 1 whole year here, right? It's broken up into eighths, but it's 1 whole year. And we've said that Fernando has been playing for not just 1, but 2 years. And then 5/8. 1, 2, 3, 4, 5. And Lana has been playing even more than that. Lana's been playing 1, 2, 3 years, and 7/8. Take away 1, that makes 7. So, how long have they both played in total? So we're trying to combine these 2 years, these 2 performers, and find out how long they've been playing as a total. So we're going to add these numbers. And let's look. Okay. I know that this is going to be a lot of counting if I want to do it as a mixed number. As a fraction. So I'm going to look at a mixed number. So first I'm going to put all of the whole numbers together. So, sorry Lana, I'm going to move your name. Okay, so I have 1, 2, 3, 4, 5 whole numbers. And then I have 5 eighths and 7/8. Now, I believe I can move this up into another whole number. Yes, I now have 8/8 here. So that means I have another whole number, and I'll move my parts away. Okay. So that leaves me with 1, 2, 3, 4, 5, 6 whole numbers, and 1, 2, 3, 4 eighths. So this means that I have 6 and 4/8.